So you see when you do these parabolas, if you find that vertex, so we're coming back to that one that we did just before, the first example was finding the vertex with negative b over 2a, that all these have symmetry. Okay, they're not always symmetric about the y-axis, okay, but they are always symmetric about the line that goes through their vertex. So here is the vertex of this one, okay, right there. And if you draw a line straight through it, that's where the symmetry is for every single parabola. And then you're going to start to see that the x-intercepts are both equally spaced over this line of symmetry. So this right here is really just a line of symmetry. So if I folded over that parabola, it would fold right on top of each other. So we call this our axis, the axis of symmetry. And it always is lined up with a vertex. So if the vertex in this case was 217, my axis of symmetry is the line x, the vertical line x equals 2. So it's not a coincidence. These are always going to be the same because it's lined right up with that vertex. Okay, so that's what we're saying down here. Because the vertex lies on the axis of symmetry, here's our equation, the full vertical line, meaning negative b over 2a, so it shares the same coordinate as the x part of the vertex. So what's the axis of symmetry from the shot put? Well, that one had the x part of the vertex was, I just have to remember, what was that one? Negative 32.52. So my line of symmetry would be x equals 32.52. So no need to use the formula again because we already used it for the vertex. We already knew it would be lined right up with that vertex. Okay, so we already, from the other activity, we already knew how to find the y-intercepts. It's always going to be this number over here. This constant is going to be my y-intercept. Because when I plug a 0 in for x, that drops out and that drops out. And that's why I always get that number at the end. So that's not a surprise. Okay, the y-intercept very easy to find all the time. X couple activities are more focused on. So for now, we're going to use the calculator. Okay, so we've got the same one again, and we already have the graph of it, and we are going to look at, on the calculator, how to find the x-intercepts. Okay, so we're back at this menu that we were just at, but now we're going to use 0. Okay, so the 0 is finding the x-intercepts, because it's finding where the y is 0. So they're pulling up, they're trying to find this one right here. So it's going to ask you the same kind of thing. It's going to ask you to bound it in and put your cursor to the left and then to the right and make a guess. And then you'll end up getting your x-intercept out. Okay, and then this one, same thing. You can find both of them. So if you go on the calculator and do this same thing, so take a few minutes, bring that graph back up for the shot put example, and then find your 0. We would only find one 0 in here, because the other one down on this side wouldn't make sense. So we only really care about that one. Okay, so is either x-intercept determined in part A significant? Yes, only the rightmost one is significant. The right x-intercept is because it gives us the horizontal, I'm running out of room here, sorry, distance when it hits the ground. Okay, so that one is significant. The one on the left is not. So let's use our results from this, from what we just did, to find the practical domain. Well, if we look at this x-intercept right here is at about 70.57. Well, that means that our domain is going to go from when it first is shot to when it comes back on the ground, which is at 70.57. I want to point one thing out up here with this y equals. This is in scientific notation. It's saying negative 2 times 10 to the negative 12, which really means that this is 0.000, and you would have 11 zeros and then a 2. So that just means it's very close to 0. Okay, sometimes you get it exactly, sometimes it's in scientific notation. Okay, one more example. Let's see. Well, let's just finish up this one here. So where is it increasing, and where is it decreasing? So it starts off increasing, okay? It's going to increase from 0 until we hit that max height, and that happens when it's 32.52 feet away from where it was shot. And then it's going to decrease after that. It's going to start coming down for the rest of them. So that, whoops, let me get rid of that for a sec. So when I pick up from 32.52, all the x's after that, all the way up until our last possible x, it will start being decreasing. In the practical range, we said, well, the max it's going to get is to 22.26 feet. So from 0 to 22.6 would be our practical range. So let's do another one where we find, I'm just going to pick one of these. Let's do, yeah, we'll do 12. Okay, so we're just going to find the vertex of another one. So we've got this parabola y equals x squared plus 6x plus 12. Okay, we're going to find the vertex. So we know the x part of the vertex is negative b over 2a. So that would be negative 6 over 2 times 1. So that comes out to be negative 3. So that's the x part of my vertex. And if you go back, is that all they wanted there first? No, they want the whole thing. Okay, so let's find the y part. If I find the y part of my vertex, I'm going to plug in a negative 3 everywhere, and I end up getting a 3 out. So I'm plugging a negative 3 in here, and then evaluating. So my vertex is negative 3, 3. So this one, this parabola is opening up because a is positive 1. So this is really a minimum for this. Okay, this is the lowest point on the graph. So use the y-coordinate to determine if the vertex is above or below the axis. So just think about where this is. I'm just going to do a little sketch. So this one, let's say that's negative 3, and then let's say that's 3. So it's something like there. And we know it's opening up because of the a value. So this one is actually all the way above the x-axis. So think about what would happen if you tried to find the x-intercepts of that. Use the value of a to determine, we already did that, we know that this opens up. So in this one I wouldn't bother trying to find any x-intercepts. It doesn't have any. This has no x-intercepts because it's above, the vertex is above and it's opening up, so it's not going to come back down. So if you graph that, you'll find the same thing. So use 13 as another exercise to find your vertex. I will just put the answers here for you so that you can check them. This vertex ends up coming out to be 4 and negative 5. And this one is opening down, so this one is below the x-axis. Okay, and this one is opening down. And this one again has no x-intercept. So just try that one. Make sure you get the right vertex, and then make sure you get the graph that looks like so it's opening down, no x-intercept. So the next activity, we're going to work on actually finding those x-intercepts by hand.